All right, we should have microphone up so that you can hear me now. Looks like it's okay. So I'm hoping. There was some kind of weirdness last month with the signal, the live stream signal being kind of low quality. I'm not sure. I'm hoping if there's anybody out there now who can give me feedback about whether the live stream feed looks particularly okay or particularly not okay, I'd appreciate the feedback. I don't know what the heck happened last time. We shall see. All right, well, I just wanted to check the microphone, so I think we're okay for now. We've got more fans running in here. Nothing like a quiet box to make things noisy. Yeah, I mean, theoretically, there's supposed to be ducking going on, so that theoretically, when I'm talking, it's supposed to suppress the music levels, which, you know, looking at the meter, it looks like that ought to be happening, but I certainly have the experience with, I'm not gonna try to screw with it right now, and 2 minutes out, we shall see. Again, hopefully, most of the time I'm not going to be talking over stuff, so it should be okay. But thanks, Ben, for the feedback. Hey folks, it's T2sday. calling today's episode Building Bottom Up. I've been going back and forth trying to decide how to build the software for this quiet box black hole for this T2.5 project that we're working on. The physicality of actually having the box is kind of important. Yiding on the T10s Discord, just idle thoughts while I slowly melt in the summer heat here. You know, the Yiding has a quiet box black hole, I believe, as well, the same as I do, and it is hot. So I decided to make a little hardware project. Software guy lost in hardware land and cooling it. So, you know, the quiet box is pretty quiet, although it's got fans, and, you know, here you can hear that it get close. You know, it's also the air conditioning. But it's got this radiator on top, just like a car radiator. It's putting out sheets and sheets of heat. And I figured, hey, I should make a fan hood and take some of that hot air and zoop it outside for climate change. And I got this new cutter, bevel cutter to use foam core. I never really figured out how to work it very well. But, you know, software guy lost in the hardware land. And it turned out that, originally I thought I was going to put the fan on top of this fan vent hood, but this foam core is like nowhere near strong enough to sit a fan on top of a sheet of it. I got a little better at doing the bevel cuts, but not very good at it. Okay, so we're just going to... So I found a piece of particle board that I figured I could just cut down to the size of the fan hood and use that to support the exhaust fan. And you have a little incompetence content warning coming up in about 5 seconds. So I didn't hurt myself, but that was extremely stupid. I hadn't used the featherboard in a long time, and I had it set up wrong. And but it was okay. I have a Band-Aid on my thumb, but that's from a separate project. So I made the fan box, and this is, the fan sitting on top of it, the exhaust fan with a vent hood that I, 3D printed, an adapter. And the fundamental problem with all of this, which I, of course, didn't know because I was trying to save money and I was just on a wing and a prayer. This is 4-inch tubing, a 4-inch duct fan, and it really doesn't move anywhere near enough air compared to how much the radiator puts out. It's kind of like square inches, So basically what's happening in the end is, you can see this is the current setup. The fan is not on the box anymore, and it's pulling air out, sending it outside. And I think it is allowing the air conditioner to work a little less hard. But in fact, it's still blowing hot air. The quiet box is blowing hot air into the room as well. Oh, there it is. Here's my bandaged thumb. The goals for today: baby P4 events. I still didn't do that. Many spikes. Yeah, I did that. Much more huge fun. Yeah, I did Ulam 6. I don't know when I'm going to get to that. So what I want to do today is run through, just as a, marking the project's, the business of the project as it goes along. Try to do a quick timeline of the software work that I did after I stopped screwing around with the vent hood, and then have just a couple other thoughts. And then, even though the current demo is very unimpressive, I want to try to save time to do a quick one, just because hopefully the future demos will be better, and then by comparison, there we are. So Okay, so the software thickens. The previous T2sday update was 35 days ago, and 25 days ago, Friday, September 12th, was me finally admitting I'm going to have to learn what PCIe is. Because PCIe, Peripheral Component Interconnect Express, or something like that, it's a bus communication technology that the TransTorrent boards and, all kinds of workstation computers use PCIe for all sorts of things these days. And I was kind of hoping I was going to be able to just use other people's code and not really know what's going on. No, that's not going to be the case. I'm going to have to be, yes, another fucking learning opportunity. And all this time I'm flapping back and forth to think, do I have to work bottom up from the Corsair's extremely low-level code, or can I work top-down from the Marty 1885 machine learning-oriented but much more fleshed-out code? Every time I try to go up, I get bitten by something and I end up going back down. That's continued to happen through September. 21 days ago, I found myself reading Linux Device Drivers, Chapter 12. I've read a number of chapters of Linux Device Drivers in the past. It's not a new book. I'd never read Chapter 12. I read Linux Device Drivers back in the T2sday hardware development when we were building our own kernel module to do the communications between the T2 tiles. And it turns out that PCIe is really just PCI in a trench code, as so often is the case. And again, I didn't know what PCI was either, but it was easily old enough that the Linux Device Drivers book explained it well. 17 days ago, I said, screw it. And tried to go top down again. 16 days ago, first demo of multicasting my own code to the fleet. So right now, there are 4 blackhole cards, each of which has 140 of these little Tenzix tiles on them. There's many layers of description and terminology, and it's easy to get them confused. So you just have to remember there's many layers, and we'll try to keep pulling them apart as we talk about it over and over again going forward. So in this case, I was multicasting the code to 140 of these Tenzix tiles in one broadcast. And that's the nature of multicast. And it was incredibly fast, like a tenth of a second. I don't know, it was already done, compared to, easily over an hour on the T2 matrix, where they were doing it in a much more robust, much more low, minimal assumptions, in definitely scalable fashion, unlike this multicast, which is all, super efficiency. 14 days ago, I was remote and I was working over the net, which is fine, supposed to be able to do that. I managed to crash Linux because I wrote a bug. I wrote a lot of bugs, but I crashed Linux so hard that I couldn't remote restart it. And that's one of the features of the Quiet Box. It's like a server that you're supposed to be able to remote power cycle. It's just like if you were there to turn the power switch off and turn it back on again. You're supposed to be able to do that by talking to the BMC, the baseboard management computer. I talked to the baseboard management computer. It said, trying to power on, trying 2 times, trying 1 time, power action failed. I had to actually come back physically to power cycle the thing. I don't know what's going on with that. By Wednesday, 13 days ago, I was now, so these Tenzix tiles that I mentioned, they have inside of them, each of them has 5 little cores, 5 little processing cores that have really weird names. There's B, T0, T1, T2, and NC. That, they don't follow a clean pattern because they're sort of meant to have different purposes. I cleaned up the code for a bit. Normally, I skip mentioning that sort of stuff, but in fact, it's really, really, really important. And especially, it's one of the things that I can do when I don't know what the hell is going on. So 10 days ago, I had managed to, when the code that's going to run on the Tenzix tiles compiles, it produces a few key addresses that may change each time the code changes on the T6 tiles. Those key addresses, I figured out a way to feed them through so that the host code in the center, that for the moment, I'm having the host code is going to be gathering information from the tiles. I have plans down the road to do it in a more distributed fashion, but step by step. Uh, uh, 9 days ago, I had the T6 tiles, the 10.6 tiles. This is the weird thing. In the code, in the TENS torrent code, they often abbreviate TENSIX, which is TENSIX. They abbreviate it as T6. And I've started doing that, and it's kind of convenient, but now it's extremely confusing. The T2 tiles and now the T6 tiles. What's going on here? In any event, they successfully, on their own initiative, instead of waiting for the host to come in and pull something out of them, which is how the first round of communication I did, this one is when they run out of space, they fill a buffer, they push it to the host all by themselves. And I've been working on that for weeks. That's why I had to learn how to do PCIe transactions and all of this stuff. So that was exciting 9 days ago. This last week, a week ago today, I broke the code so badly that I could not back my way out of it. No matter what I did. Mud 14, the current spike that I was working on at the time, I broke it so bad I couldn't recover. So by T-minus 5 days, I actually just killed it and restarted, made Mud 15 be a copy of Mud 13 and came forward much more carefully. And I don't know what I did wrong. It's very unsatisfying. I redesigned the transport system, because, well, again, without going into the details, but the point is the flavor of going higher, redesign going lower, PCIe going even lower, register addresses and bits and flags, and then flowing back and forth between all these things. This is what, for me, this is what experimental system design is all about. And I want to keep it multiple levels, soft, design-wise, if I possibly can, so that I can allow news and views and issues from lower level to come up and affect higher levels of design and so forth. 3 days ago, I did another code cleanup, and also I finally was ready to give up on trying to figure out the clean, perfect, general way, that particular design problem that I was trying to do, so that it would be totally flexible and in the future and so forth, and it was causing all kinds of troubles. So I made some compromises. I just said, no, well, this will work for now, but it's very specific and so forth. So there we go. And then yesterday, I made this timeline and so forth, and here we are today. So that's what I've been doing for the last month. How about you? What have you been up to? And all right, news and muse. Just made that up. It sounds a little silly. So the news item I wanted to mention was that the Artificial Life 2025 conference is happening right now in Kyoto, Japan. And this is now the second year in a row that I haven't gone, even remotely, even by remote participation, but I didn't have anything written up. And, there's lots of people there that, I would be happy to talk to and I would be happy to meet with and so on and so forth, but sigh. And there's also already some interesting papers that I downloaded PDFs and started taking a peek at. So that's happening. One of the things, this is a muse now, very briefly. The TENS torrent black hole hardware is very articulated. There's little bits of hardware for all kinds of special purposes, little mailboxes to connect between the baby RISC-V cores, and a couple of different kinds of mailboxes and all kinds of things. Counters, timers, you name it. And that makes it hard to get to know because there's a tremendous amount of stuff. But what it is not is this simple, pure, clean idea where you have this is it and everything is stomped out identically like the boxes made of ticky-tacky in suburban United States. And on the one hand, the T2 tiles by design are, you stamp them out. They're exact. I mean, they have some gizmos inside the T2 tile, but nowhere near as much as the TENS torrent hardware and the black hole hardware has. And I had dumped on this approach when I was talking about indefinite scalability, that, you know, at some point you have to get to something that you can just stamp out. You can't have to add a few more special little gizmos. So I dumped on Intel about adding extra gizmos a year or two ago in the Intel versus Tesla, when Tesla wasn't horrible, AI chip competition. So it's been very interesting, and I have to admit that when I find I can use one of the gizmos and the gizmo works, I feel happy. It's like, ooh, that's nice. So we're getting to know it. All right, to-dos and to-dones. You know, I keep talking about having huge fun. It's not as easy. You know, slogging through it. Some of it is a struggle, and so the huge fun is as much in retrospect as anything else. I wanted to quickly take a look at my to-do list. This is what it looked like at the last T2sday update. I got a few green check marks there up about the BMC getting the computer going, the BMC and then having the problem, and the getting the fan and cooling in the room a little better and so forth. But it's going pretty slow, and that's where we are right now. So as far as the things that I'm proudest of is that, you know, we've got like debug printf is actually working. So, well, I tell you what, let's take a really quick look at the demo. All right, so here it is. So I'll rebuild it. And boom. So at the moment, it's that quick. That's recompiling the code that's going to run on the 10.6 tiles. It's going to run on the fleet of 140 of those things, and it's also compiling the code that's going to run in the central x86 server. And now let's just run it. Run, and it's over in a second. And okay, there it is. And, you know, what's going on? Well, you know, it's a bunch of phases that I've made up. So in the first phase, it prints out a whole bunch of configuration information. This log storage, transpo info, that was some of the stuff that I was talking about before, about information about the T6 tiles that has been centralized. And then we start allocating stuff, allocate host buffer space. There's more of that goes on. This is, I had to learn about, well, anyway, you don't even want to know. But now I know about using mmap to shadow space so that when I get a block of memory, the transportation, right, and then put all the cores into soft reset. So this is the sort of, you know, synchronous thing that you can do is, you know, broadcast one 32-bit word to all the cores and they all stop running. Like, can't do that with the T2s. You have to go land war step by step by step. So once they're in reset, we can set the starting addresses, then bam, this is deploy the code. That's what I was talking about, where, you know, it's over before you saw it. And then finally release the hounds. It used to be that I would reset all of the T6 5 little baby hearts, they call them, at once, whereas that turned out to be a bad idea, because there's a bunch of initialization that really needs to be done just by one of the hearts inside each T6 tile. So now I just release the B heart, and it does the once-time setup, and then it releases T0, T1, T2, and NC when it's good and ready. And then here, this is information from the log. This is the T6 tiles sending stuff under their own initiative to the host, and the host printing it out. So voila. So that's what it felt like. That's the demo of the state of the ticks. So next month, November 24th, is going to be the last T2sday update in 2025. I'm going to take November off to work on other writing, but also before then, so during October, I want to get not just baby P4 events, but toddler P4 events. I want to see fork bomb and dreg res of some sort running on the host where we can actually see it. Could just be curses, you know, it doesn't have to be fancy graphics, but it has to be events that are actually running out on the fleet and are somehow being merged. Have tons and tons more fun, and so forth. Thanks so much for checking out the project. I hope you've have something that you've been building too. Everybody should be making something. And I hope to see you next month. All right. Well, I can hear the fan going, so that's pretty sad. Uh, but that's because the AC is off. Let's turn the AC back on because it's hot. Uh-oh. And we'll see how we're doing. So, I guess at this point it's turning out to be 20-minute updates by default. I didn't even announce it ahead of time this time. But in any event, okay. Yeah. All right. Yeah. So Wayne, I think the audio sounds fuzzy when I speak. I think it's because the fans that are still running. I'm pretty sure I haven't gone. I'm not pinning the audio meters or anything like that. I suspect it's fan noise that I've got a suppression filter on it, a real time suppression filter that's supposed to cancel the noise out, but it doesn't seem like it does that good a job. It seems like it's acting more like a noise gate. So when the total volume is below a threshold, it crashes it to zero, which is fine. But then when the total volume is not zero, because I'm talking, a lot of the fan noise comes through with me and makes it sound crappy. So I apologize. Like that. The mic rubbing is something. Well, I may rub onto it. The mic is right here, so I might rub onto it, but I think it's okay. But it's the fan noise, and really need to have the studio and the workstations not in the same room. But it's a lot of stuff to figure out, you know. Yeah. And is the multicasting done through PCIe? Well, kind of. IPv4 when I hear multicast, yeah. So the way the TENS torrent cards work is when you want to communicate between the fleet, between a 10.6 tile out in the fleet and the host, you first send a packet across the network on chip, the NOC, which is custom for TENS torrent. It runs their own custom stuff. And there are special tiles on the blackhole chip, on all of their chips, that have special purposes. In addition to the 10.6 tiles, which are the general compute workers that I'm focusing on, there's special tiles that interface with RAM, there's special tiles that interface with Ethernet, and there's special tiles that interface with PCIe. So the way you send a message from a 10.6 tile to the host is you send a NOC packet on the local network on chip to the PCIe tile and ask it to package up your data in a PCIe transaction and send it on to the host. So that's the inbound way from the fleet to the Admiralty. When you're going in the other direction, which is what we're doing for broadcasting, we do PCIe transactions, but they're not multicast. The PCIe part of it is unicast to the PCIe tile, which then delivers it onto the NOC, and the NOC does a multicast. The NOC can send to a rectangular subarray of any of the T6 tiles on a given, black hole tile in this case. And because of the weird way that all the tiles are laid out, if you pick a rectangle of tiles, you may rope in some of the ones that are not actually 10.6 tiles, but they automatically say, sorry, no thanks, and just pass it along. I don't eat that food. They decline the multicast, but continue to route it on to downstream ones. So the multicasting is done indirectly by the PCIe, but mostly it's done by the NOC. That propagates across and down and fills in a whole little rectangle. As an Intel fan, I kind of like the gizmos. Well, we'll find out. I mean, where I'm going to land on this. And, historically in the reduced instruction set versus complex instruction set, that whole story, there was the problem that the complex instructions took a lot of transistors to implement, and if they weren't just what you needed, those transistors would tend to go to waste. And I mean, that's what's happening with these giant matrix multipliers and so on and so forth that the 10s card has. Given that at the moment I don't have a purpose for them, but we'll see. So that's the risk with the gizmos, and I mean, they are infuriating in one sense because lots of design decisions were made. For example, the mailboxes that I'm using that talk between the hearts. Hey Gert, and the mailboxes that talk between the tiles, you can tell if there's any mail for you, but you cannot tell if there's no room for you to send another message. Like that. So I had to figure out a way to work around it, because I wanted I wanted Heart T2. Its whole job to be to run the random number generator and send numbers by mail, random numbers by mail, through the little mailbox system, the gizmo that the black hole chips, the 10-6 tiles have. But I couldn't just write something and then go on and see if someone else needs mail, because if there was no more room for them to read, then I would block and I wouldn't be able to go on and check the rest of them, because each heart is one thread of control. So anyway, if you try to reduce instruction, the situation gets a bit risky. Okay. Samter, he's got a pun in a circle. It's a job requirement. Yeah, superscalar. Yeah, I mean, CPU design has come a long way. It absolutely has. And even if it's a little difficult to tell, I mean, we have benchmarks, right? We say if it's working faster on a benchmark, that's good, even though nobody cares what the benchmark is computing. Everybody's actual workload is something else, which is related to the work, the benchmarks by however it is and however it isn't, like that. And so one thing that's kind of funny to me is the 10s torrent folks in their marketing, they stress over and over and over again that, well, not just in their general marketing, but in particular their marketing to the developer community, that the RISC-V cores in the 10-6 tiles, the ones, the B, T0, 1, 2, and NC, are baby RISC-Vs, because they're desperate to lower expectations of what people are going to be able to do with them, because all they're supposed to be is a controller for these giant matrix engines and vector engines that are stuck on the side of each 10-6 tile. And if you do what a normal developer would do, which is just think, ooh, 5 cores, I could do it, blah, 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 like that, then you're likely to be disappointed, because they are pretty wimpy cores. But in exchange, they're tiny, and that's why there can be so many of them. 140 times 5, plus a whole bunch of others on every chip, on every black hole chip. So that's the trade-off. And my experience so far is that, they're plenty perky. I'm used to the T2 tiles that run at 800 megahertz typically and top out at a gig, and have communication that's measured in the 100,000 bits a second to the neighbors, like that, with a tailwind on a good day. In the NOC, the communications that go from T6 tile to T6 tile through the network on chip. In the black hole, I think this is true. The bus is 128 bits wide. So every clock cycle, another 128 bits is moving down the network. I mean, moving down each channel of the network. If you manage to get the whole grid cooking, I mean, it's insane like that. And as a result, you know, differences in quantity become differences in quality. You could consider doing different things. When RISC was coming around back in the 80s, yeah, I mean, I remember, you know, my favorite cut my teeth machine was the PDP-10, which, you know, had a complex instruction set, but I loved it. And the things you could do with byte pointers on a PDP-10, never been able to do anything as beautiful since, as far as I'm concerned, like that. Yeah, it's incredible. 128 bits times a gigahertz times every branch of the grid. I mean, this is the individual hop to go from one to the next one over. It's really fast, and so, you know, in fact, I was worried a little bit that the PCIe bus is going to be the bottleneck as far as, you know, sending stuff back to the host, and, you know, eventually it will be, which is why, you know, after we get a little more familiarity and get events running and so forth, we'll try to distribute the merging of the event windows so that happens out in the fleet as well, rather than just going all the way up to God and let God sort it out, which is a particularly poor method of scaling. Anyway, so yeah, 8080 took 4 clock cycles. There's actually something on the T6 tiles that one of the things I mean, I've read so much stuff in the last month, and I don't retain it all because I didn't understand it all. It's only the little bits that actually made sense that I am able to lock in because I have an angle that little fact supports. But there was something that there's a number of different ways to do a no-op, like adding 0 to 0 and storing it in the register that's always 0. You know, that's one way of doing a no-op on RISC-V and so forth. And there was one way of doing a no-op that for some reason took a long time. I don't know if it was 4 clock cycles or maybe it might have even been more. I don't remember exactly what the deal was there. It was something to do with memory latency and you know, whatever. But anyway, so I really wanted to get to events running for today. I mean, you know, I'm getting slower. I can't stay on task as long as I used to be able to in my 30s and 40s, or 50s and 20s. I'm not sure. But you know, I keep plugging away at it and so forth. And this has been a pretty steep learning curve so far. So it's a lot of, you know, technical mountain climbing and falling down and breaking my head, starting up again. So it's very much step by step, but you know, I feel good. I feel like, okay, I'm learning some new stuff, and I've got bits and pieces of the code that do sort of cool things. A down payment towards more cool coming later. Okay, folks. Thank you so much, the folks that managed to make the time. Now Wayne's going in for surgery tomorrow, so let's make sure we wish Wayne good luck. And I had the surgery, and it was actually great. It helped a ton, and it's been fine. I have this opinion that some surgeries are good surgeries, some surgeries are bad surgeries, in terms of the value per in exchange for the inconvenience and risk and money and so on. Like that. One must imagine Dave Happy. I do okay. I do okay most of the time. I get cranky sometimes, and I get frustrated certainly. But one thing that I think is true, that the older I get, the better I get at kind of being happy. Like that. So yeah, good luck, Wayne. Schlabbermouth, thank you too. All the best, and I'll see you folks, as many as possible, in a month, and then in the Discord or whatever, if folks can drop in there. Okay, so I guess that's that. I got a little heart. I can make a little heart too, right? Get the actual window up. Oh, there it goes. Yeah, now I can make some hearts. Oh, I'll make some hundreds. Those are good. Engage with my audience by pretending to be your audience is the idea. Okay, all right, good enough. Thanks, folks. Step by step.